Recently, our client Tommy met his banker to discuss continuing his father's restaurant legacy. In us, he found a partner that understood the importance of passing the torch. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John.
This is SpaceTime, Series 26, Episode 140, for broadcast on the 22nd of November 2023. Coming up on SpaceTime, Cerberus Foci identified as the biggest source of Marsquakes. A new discovery pushes forward how soon life could have begun in the universe, and why size matters if you're an exoplanet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study of data from NASA's Mars InSight lander mission has identified the Cerberus Foci region east of InSight as the red planet's most seismically active. Since its arrival on Mars back in February 2019, InSight's recorded some 1,319 Marsquakes, the biggest reaching a magnitude of 4.7. After 4 years of operations, the lander was finally retired last year when its solar panels were covered in so much Martian dust they were no longer able to collect enough sunlight to power the spacecraft. During its operational life, scientists found that most Marsquakes are the result of meteor impact events. However, orbital observations failed to find any significant new impact craters which match the big 4.7 quake timeline. It's therefore believed that the giant 4.7 magnitude event must have been caused by the release of enormous tectonic forces deep within the Martian interior. Earth's crust is divided into immense tectonic plates, which are continually shifting, sliding and subducting past each other, triggering quakes. But the Martian crust is one single solid plate. Mars doesn't have any active tectonic plates today. So the big 4.7 event was likely caused by the release of stress deep within the planet's crust. Now that would happen because Mars is still slowly shrinking and cooling, and so there'd still be motion within the crust even though there are no active tectonic plate processes going on. Among its many readings, InSight recorded 98 low-frequency seismic events. And despite the fact that InSight is the only seismic station on Mars, mission managers were still able to isolate the Cerberus Foci region as the source for many of them. The study's lead author Savas Solan and colleagues from the Marsquake service were able to circumvent the problem by using the clearest events as benchmarks in order to trace the origins of less distinct seismic activities. They wound up compiling a large catalogue of seismic events, clustering in a north-south band encompassing Cerberus Foci. And a check of orbital observations shows that this region of the red planet exhibits signs of recent faulting and also possible volcanic activity. The authors also found another cluster of seismic activity along the dichotomy boundary that separates the Martian southern hemisphere highlands from the planet's lower northern plains. Notably, the study pinpointed 5 seismic events in the vicinity of the Western Valles Marineris, the giant split in the Martian crust which dominates the planet's surface features. And they also found events near the southern fringe of Olympus Mons, the largest volcano in the solar system. Neither area had previously been associated with current tectonic activity. And as for that massive 4.7 magnitude event, well, the researchers determined that it was centered around the Alquajira Valles region of the Martian southern hemisphere, roughly 2,000 kilometers southeast of InSight's location, just north of the equator. They think it probably originated around a dozen or so kilometers below the surface. A spectacular event by any account. This is SpaceTime. Still to come, how soon could life have commenced in the universe, and why size matters if you're an exoplanet. All that and more still to come on SpaceTime. A new study shows that oxygen, one of the key ingredients for most life on Earth, was already in abundance in the very early universe. The findings, reported in the Astrophysical Journal, are raising fascinating questions about how soon after the Big Bang the chemicals necessary for life existed. The study is based on new data from NASA's Webb Space Telescope, which was measuring the abundance of oxygen in the early universe. The findings showed that the amount of oxygen in galaxies increased rapidly within the first 500 to 700 million years following the birth of the universe 13.8 billion years ago, and it's remained as abundant as observed in modern galaxies ever since. The early appearance of oxygen indicates that the elements necessary for life were present much earlier than expected. In the early universe, shortly after the Big Bang, only light elements such as hydrogen, helium, and trace amounts of lithium existed. These are elements created in the Big Bang itself. All the heavier elements, those which astronomers refer to as metals, including carbon, oxygen, iron, and so on, were all formed either through nuclear fusion reactions within stars or when those stars died, and were then dispersed through galaxies, primarily through events like supernova explosions. This ongoing process of elemental synthesis, unfolding over the vast expanse of cosmic history, created the diverse elements that constitute the world and living organisms around us today. The research team, led by Kimiko Nakajima from the National Astronomical Observatory of Japan, used data from the Webb Space Telescope to measure oxygen levels in 138 galaxies that existed in the first 2 billion years of the universe. They found that most of these galaxies already had oxygen abundances similar to what we see in the universe today. In fact, they found that they really needed to look as far back as galaxies that existed when the universe was only 500 to 700 million years old before they found significant amounts of oxygen-poor galaxies. 6 out of 7 galaxies they examined from this early time period had roughly half the predicted oxygen content. Now, what this means is that a rapid increase in oxygen content must have occurred far earlier than what scientists were expecting. Importantly, it opens the possibility that, with the necessary ingredients like oxygen already available in the early universe, life may have appeared much sooner than previously thought. This is SpaceTime. Still to come, why size matters if you're an exoplanet, and later in the Science Report, Australian researchers design and build a synthetic chromosome which can be incorporated into a yeast cell. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Scientists may have finally solved one of the great mysteries surrounding the size of exoplanets, that is, planets orbiting stars other than the Sun. Astronomers have confirmed the discovery of well over 5,000 exoplanets so far. They range in size from Jupiter-like gas giants and sub-Neptunes at one end down to rocky super-Earths and smaller at the other. But there's a conspicuous gap in the middle. Astronomers have never found a planet that fits in between a sub-Neptune-sized world and a super-Earth. That is, planets that fall in a size range of 1.5 to 2 times the size of the Earth. Now, a new study reported in the Astronomical Journal may finally have found the answer. The study's lead author, Jesse Christensen from Caltech, says this gap isn't a fluke. There's something going on that impedes planets from reaching and or staying at this size. Christensen and colleagues, using NASA's retired planet-hunting Kepler Space Telescope, believe the cause of these missing planets are quite literally pushing their atmospheres from the inside out, making them smaller. Now, this loss would happen if a planet doesn't have enough mass and therefore gravitational force to hold onto its atmosphere. And so sub-Neptunes that aren't massive enough would shrink to about the size of super-Earths, leaving a gap between the two planet sizes. Christensen believes the likely culprit is core-powered mass loss, which occurs when radiation emitted by a planet's hot core pushes the atmosphere away from the planet over time, and that radiation is pushing up on the atmosphere from underneath. The other likely explanation is photoevaporation, which happens when a planet's atmosphere is essentially blown away by high-energy radiation from its host star. While photoevaporation is thought to occur during a planet's first 100 million years, core-powered mass loss is thought to happen much later, closer to 1 billion years into a planet's life. Christensen and colleagues used data from NASA's K2, an extended mission of the Kepler Space Telescope, to look at the star clusters Prasepe and Hyades, which are around 600 million to 800 million years old. Because planets are generally thought to be the same age as their host stars, the sub-Neptunes in these systems would be past the age where photoevaporation could have taken place, but not yet old enough to have experienced core-powered mass loss. So, if the authors saw there were lots of sub-Neptunes in Prasepe and Hyades as compared to older star systems in the cluster, then they could conclude photoevaporation hadn't taken place. In that case, core-powered mass loss would be the most likely explanation of what's happening in less massive sub-Neptunes over time. In observing Prasepe and Hyades, the authors found that nearly 100% of stars in these clusters still have a sub-Neptune planet or planetary candidate in their orbit. And judging from the size of these planets, the authors think they've retained their atmospheres. And this differs from other older star systems observed by K2, stars more than 800 million years old, where only around 25% still have orbiting sub-Neptunes. See, the older age of these stars is closer to the sorts of time frames in which core-powered mass loss is thought to have taken place. So from these observations, the authors have concluded that photoevaporation could not have taken place in Prasepe or Hyades. If it had, it would have occurred hundreds of million years earlier, and those planets would have had little, if any, atmospheres left. This leaves core-powered mass loss as the leading explanation for what's likely to be happening to the atmospheres of these planets. This report from NASA TV.
You've seen weird, wonderful worlds in science fiction. We don't yet know what sorts of life might exist out there, but some of the planets, not unlike the ones in your favorite stories, are real. At NASA, we're studying them. They're called exoplanets. The term exoplanet means a planet outside our solar system, a planet that doesn't orbit our sun. Most orbit other stars, but some are just sunless wanderers out in the space between the stars. Now, just the fact that they orbit other stars means exoplanets are extremely far away. Most are too far to even dream of sending space probes to explore them. So we study them in other ways, like with telescopes on the ground and in space that can observe these far-off planets from right here in our solar system. Here's the thing about exoplanets. They are everywhere. In fact, from our observations so far, we know there are more planets than stars. So, there's our solar system, then there are all the billions of planetary systems in our galaxy, the Milky Way. Then there are all the billions of other galaxies. Basically, there are a lot of exoplanets out there. Each of the stars you see in the night sky is the sun for any planets that orbit around it. But not all stars are created equal. Bigger stars burn way brighter and hotter and don't last as long. Smaller, fainter stars like our sun and red dwarf stars last much longer. But even nice, cool red dwarf stars can have powerful flares that blast their planets with radiation. We're still trying to understand which kinds of stars provide long-lasting, stable conditions that could allow life a chance to take hold and evolve like it did here on Earth. Exoplanets are super hard to see, both because they're so far away and because they're so much fainter than their stars. But we've worked out some clever methods to detect them and even take pictures of some. So, what can we observe? Well, for many, we can determine their size, their mass, how much they weigh, and how far away from their stars they orbit. From these and a few other clues, we can infer a bunch of other qualities, like how hot or cold it might be on their surfaces, or if they even have surfaces. We can tell that some are gas giants like Jupiter, while others are like bigger, bulkier versions of Earth. For some, we can determine they have atmospheres and even some of the gases in those atmospheres. Most exoplanets are very different from our planet. They have a lot of weird, wild variety, with gas giants much bigger than our own Jupiter, and other planets with oceans of lava or rainy glass, or even gemstones. Funny thing is, looking at how they're arranged as families of planets, we don't see a lot of exoplanet systems that look like ours so far. Many are arranged quite differently, so we might actually be the weird ones. Some planets are closer to their stars, some are super far. Some even orbit multiple stars. Imagine having 2 or 3 suns in the sky. So why do we study exoplanets? Well, our interest in finding worlds with life on them is a big factor. We want to know more about what makes a planet a place with all the right ingredients and conditions for life, what scientists refer to as habitability. How does it happen? How common is it? We think the most life-ready planets are the ones most similar to Earth, with a range of qualities that include similar size and composition to our planet, and being at the right distance from their stars to have liquid water on the surface. These qualities are really challenging to observe from so far away, but we're working on it. Exoplanets teach us a bunch of other things too. Studying other planetary systems helps us better understand the story of our own planet family, including Earth. Scientists detected the first exoplanets in the 1990s, but now we're finding tons more, thousands so far. We're studying their atmospheres and even making weather maps for some. We're surveying exoplanets to understand all their variety. And the more we learn, the more it powers our curiosity, the more we want to explore exoplanets, planets outside our solar system.
This is SpaceTime.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you, Fargo? You can. In the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
With no fees or minimums and no overdraft fees, banking with Capital One is the easiest decision in the history of decisions. Even easier than choosing to keep the Grinch away from the toy drive.
Who's going to deliver the toys to the kids?
What about me, the Grinch?
No.
Yep, even easier than that.
You steal the presents one time.
With no fees or minimums and no overdraft fees, is it even a decision? That's banking reimagined. What's in your wallet?
Terms apply. Capital One N.A. member FDIC. Copyright Dr. Seuss Enterprises. Copyright Turner Entertainment Company.
And time now for another brief look at some of the other stories making news in science this week with a science report. Scientists are warning that heat-related deaths are likely to see a 4.7-fold increase by mid-century under current global warming trajectories. The findings, published in the Lancet Medical Journal's 8th annual Lancet Countdown on Health and Climate Change report, brings together research from 114 leading experts around the world. The study assesses links between health and climate change. The authors looked at the threat that global warming currently poses to lives and livelihoods around the world, highlighting how each region is faring in mitigating the health impacts of climate change and assessing current efforts to transition to clean energy. After 7 years of research, scientists with the ARC Centre for Excellence in Synthetic Biology have designed and built a single yeast chromosome that takes us a step closer to having the world's first yeast strain with an entirely synthetic and versatile genome. The groundbreaking research by Australian scientists is part of the Global Yeast 2.0 project. A report of the journal Cell Genomics claims the new synthetic chromosome pushes scientific boundaries to help pave the way for a thriving bioeconomy. A new study warns that people who are never visited by friends or family are likely to be at a higher risk of dying early. The findings, reported in the journal BMC Medicine, are based on research investigating the link between loneliness and death risk. The authors based their findings on data from 450,000 patients in the UK Biobank study and asked them about their level of social interaction, how frequently they could confide in someone, how frequently they felt lonely, how often friends and family visited, whether they did weekly social activities, and whether they lived alone. Following up over a decade later, the researchers found that all 5 of these factors influenced a participant's risk of death, with the greatest risk of death most strongly linked to never having visitors. Now, the researchers noted that this study is reliant on relatively simple self-reported data. However, they say it could help inform future research on risks of loneliness and how to counter them. Google have announced plans to free up valuable cyberspace by closing old Google accounts that haven't been used for at least 2 years. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, if you've got a Google account that, like it's a spare one that you may have used for anti-spam purposes, or it's a loved one's account that maybe is no longer with us, but you are looking after it. If it's been more than 2 years old, starting from December, Google will delete that and reclaim all the space because they've got millions of inactive accounts that are just sitting there and chewing up space, being backed up. So if you've opened up a Gmail account for whatever reason and you haven't bothered to log into it, look, you may wish for it to go. You may not care. So just a warning that unused Google accounts, if you really want to keep them, if you haven't used them for 2 years, they'll be gone starting from December 2023.
NVIDIA's next generation chip's been released. Tell us about it.
Yeah, this is called the H200. It's nearly twice as fast as the H100 before it, but it's being used in their thousands to power OpenAI's ChatGPT 4. Now, OpenAI is already working on ChatGPT 5, and it will need more powerful chips. And currently, these chips are costing anywhere from $25,000 to $40,000 US each. I mean, that's one of the reasons why NVIDIA became $1 trillion company recently. So they've got their next generation chip. It's something that all of the different generative AI providers are going to be using, even though all of the chip makers, be it Qualcomm or Intel or AMD, even Apple, talk about being able to run AI applications directly on device. We still need these super powerful chips that operate in data centers and super fast supercomputers, and NVIDIA's latest chip, just announced, is twice as fast. So expect even better ChatGPT-style applications in 2024 and beyond.
The new cyber report from the Defense Signals Directorate has come out. It's not surprising that China are on top of the list of countries to worry about.
Yeah, look, they say that nearly 94,000 cybercrime reports were reported to report cyber, and that's an increase of 23% compared with last year. So on average, there's one report being received every 6 minutes. So the cyber criminals certainly ramped everything up during COVID, and they haven't stopped.
There used to be one report every 7 minutes last year and one report every 8 minutes the year before. So it's a fairly significant increase, yeah.
Yeah, it's absolutely speeding up. And, the top 3 types of cybercrime being reported should come as no surprise. It's identity fraud, online banking fraud, and online shopping fraud. So, anything to do with finances and money is being attacked viciously by cyber criminals, and not just from China, but, from all over the world. But obviously, it's the nations that have very advanced cyber hacking teams that
China, Iran, and Russia in that order, I believe.
Yeah, and North Korea is in there as well, no doubt.
So you've got the full axis of evil, as they call it.
Look, the ASD Cyber Threat Report can be downloaded free of charge. You've got the link at techadvice.life, but you can just go to cyber.gov.au and read the full report for yourself.
And what else is on the website this week?
There's a link to Fedora version 39. That's a version of Linux that's just turned 20 years old. There's also information about Google and Sydney Airport launching their indoor live view, and reports that Apple is about to infuse AI into all of its operating systems for 2024. They're feeling the heat from Microsoft, Google, and all the rest, and they're spending billions to make sure that this time next year it'll be Apple AI everywhere.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.